How many people know what mitochondria are? So some of us around the room, show how many of us would probably like to know what on earth it means and why is it of relevance to us. So a little bit of history. Mitochondria, well, they come into play in evolution 1.5 billion years ago. Once an evolution event took place, a big bacteria eats a wee bacteria, and rather than chomping it up and getting all the bits and going, it's me fed, something strange happened. The wee bacteria that was consumed by the big bacteria, they kind of made friends and they found a symbiotic way to exist. And the wee guy said, listen, if I feed you some energy, can you give me a nice, safe, secure home? Effectively, words to that effect. They decided they could exist. And this process of what became the mitochondria in a cell fed, the cell energy, and the cell was able to do things it couldn't do before. It's led to complex life that we're part of, and the plants and all the kind of things that we experience in life. So that's where mitochondria come in. They are the powerhouses of our cells. We would not exist without them. Now let's look at the brain. In fact, despite the fact that your brain accounts for just 2% of your body weight, it requires 20% of your energy demands of your body. So 2% weight, but 20% of the energy that your body needs is consumed by the brain. So really, really heavy kind of sort of energy demand. And it's the mitochondria that have that demand that need to be fed. Let's have a quick look inside the brain and we'll try and understand why mitochondria are so key to Parkinson's. Some neurons might only have a few hundred mitochondria, and you have them in the neuron itself, but you also need mitochondria to fire and to work and to interact. As you go up in levels of complexity, you might have a few thousand mitochondria in these neurons, maybe tens of thousands, maybe a few 100,000 in some of the more complicated ones. Can anyone tell me where the most complicated and energy-hungry neurons are in the brain? It's the substantia nigra. And what goes wrong in Parkinson's? It's the dopamine cells in the substantia nigra. So it is the most energy-hungry cells. Compared to a few hundred mitochondria, this is an example of a dopamine neuron. Between 1 and 2 million mitochondria. Can you see how much energy demand that part of the brain that's going wrong for us right now? Vicious